We are finally making it to the end of the chapter. So this is our last video for chapter number 2. So what have we done so far? We know how to do scientific notation. We know about measured quantities, the different units, how to determine the certain digits and the estimated digit. We know the metric system and the SI system. We know how to convert one step and multiple steps using conversion factors. And we also know how to do a conversion where you're changing a numerator and a denominator on the same sequence or the same train track setup. So what do we have left? We're gonna do more conversions, but this time the conversions are gonna have powers. So basically the same thing you have been doing, but with a little variation. And then we're gonna go into what density is and how to use density, which is nothing more than mass divided by volume, or the amount of matter that you have by the amount of space that it takes. And we're gonna use that as a conversion factor also. Given the mass, can you find the volume? Given the volume, can you find the mass? Assuming that you have the density. So let's begin with convert units raised to a power. And what better way to do that than doing it with a problem? So this problem is asking us to find cubic feet given a cubic yard. So if I have 1 cubic yard, can I translate that into cubic feet? And it's telling us that there are 3 feet in 1 yard. So our conversion factor is, for every 1 yard, we have 3 feet, or for every 3 feet, we have 1 yard. Conversion factors are just fractions that we can flip up and down, right? So, train track method. We don't want the yards because we want the feet, right? And we know that 1 yard equals 3 feet. But if you notice, yards cancel with yards, but what do we do with the cubic? 1 is cubic, the only one is just to the power of 1. So for us to be able to do this, it has to match also the power. So what we do, we cube everything. In other words, we are cubing that, and we are cubing that. Same thing. So what happens there then? Well, the cubic yards cancel with the cubic yards, and that gives us what remains, which is the cubic feet, which is what we're looking for. So this is going to be 1 multiplied by 3 to the cubic divided over 1 to the cubic, which is nothing more than 1 times 9 over 1 cubic feet, or just 9 cubic feet. So 1 cubic yard is going to be the same as 1 cubic feet. So remember, all you have to do is cancel the units the way we did it before, but if they have a power, make sure that the whole conversion factors receive that power. So you're gonna be giving the power to the unit like feet, and you're also gonna be giving it to the number, like on this case, 3 for 3 feet. So it became 9 cubic feet. So let's see if you can do that then, based on that example I just gave you. It's telling you that there are 36 inches in 1 yard, and it's asking you to find how many cubic inches you're going to have in that many cubic yards. So using the conversion formulas that you had before, like 1 inch equals 2.54 centimeters, 1 gallon is 3.78 liters. Using that table, find whatever you need to find to be able to do the train track for this problem. So let's continue moving forward. What about this one here? Earth has a surface area of 197 million square miles. What is the area in square megameters? So given 197 million, so that would be 10 to the 6 square miles. What would that be in square megameters? I can tell you right now that this is not going to be just one step. And we know that 1 mile equals that. So we know 1 mile is the same as 1609.34 meters, or 1609.34 meters equals 1 mile. So given the miles, can we make it to megameters? Well, the only thing we have so far is going to meters. So let's go to meters first. From miles, I don't want the miles because I want the meters. And I know that 1 mile equals 1609.34 meters. But I do not want to cancel just the miles. I have to cancel square miles. So I'm going to square on top and square at the bottom. And that cancels the square miles. And now I'm going to have 16.09.234 squares times meter squares, but I am not looking for meter squares. I'm looking for megameters. So I do not want the meters because I want the megameters. The one with the prefix is this one, so that one gets the 1, and mega means 10 to the 6. Remember the prefixes? But I don't want to cancel meters. I want to cancel meter squares. So I square everything, top and bottom, and now I can cancel meter squares. So what units do we have remaining? Mile squares is gone, meter squares is gone. The only unit remaining is the one I'm looking for. So what do I need to put on my calculator? Well, on your calculator, you're going to put 197 10 to the 6 times 1609.34 to the square times 1 to the square divided by 1 to the square, which is just 1, right? And 10 to the 6 to the square. And you have a lot of keys on your calculator that will allow you to do that. If you need help with that, just let me know or go to the Science Learning Center or something like that, but that's just the math. The chemistry we already covered. So if this was a 10-point questions on the test, if you make it up to this point with those units, you got 9 out of 10. The rest is just doing the calculation. Calculation is not the important thing. It's showing that you know how to do it. So once more, what we did was, if you have a power, make sure that the unit have the same power. And if the unit has a numbers on front, those numbers also have to be elevated to that power. And the rest is what we did before. Given a unit, can you find another unit using as many connections as you need based on the values that you know. For example, we didn't know how to go straight from miles to megameters, but we knew how to go from miles to meters. And from meters, we knew how to go to megameters using prefixes. So with that said, go ahead and work on that one. So given 435 acres, can you say how much is that in square meters? And the information you're given is basically acres to square feet or acres to square feet and miles to feet. So how can you use that information to connect everything you need to connect? If you need to go to the big table that we used at the beginning on one of the previous recordings, then make sure you go there and find whatever you need to find. And with that, pending more practice, obviously, so that's what you have the tutorial videos. You can call me, whatever you need to do. You can go back to the textbook, watch the PowerPoint, or come back to this recording and listen to it as many times as you need. So given that, we're going to move forward to the next objective. Calculate the density of a substance. Use density as a conversion factor. Well, first thing, if I ever ask you what is density and you tell me, oh, density is mass divided by volume, that's going to be wrong. Out of 10 points, you probably lost 8 points because that's not what density is. That's the formula to calculate density. What is density? Density is the relationship that exists between the mass of a substance and the space that it takes. And if I ask you to explain density to a 6-year-old, how would you do that? Well, you can probably do something like this. Imagine you have a substance made out of molecules. And we can see that this substance takes all this space. Imagine the same substance in a different situation. And now you can see that this substance takes all this space. Question number 1. Is the mass of the first object equal or not equal to the mass of the second object? So the mass is based on the blue color circles, right? So how many circles do I have on the first one? I have 10. On the second one, I have 10. So the mass should be the same. If the volume of the first one the same as the second one, obviously you can see that this one is bigger than this one. So obviously they are not equal. And going back to the mathematical definition of density, density is the mass divided by volume mathematically, not chemistry. So which one will have the higher density? The higher density will be that one, because you're going to be dividing the same mass by a smaller number. So B1 is smaller than B2. So what can we say about density? The closer the particles are, the more dense something is going to be, because it takes less space. That's very different from saying density is mass divided by volume. And that's what we just did. What is density? So we know how to calculate it, right? We can calculate density by taking the mass of the substance and dividing it by the volume. Usually, it's going to be grams over milliliters. If it happens to be a liquid, if it's a solid with a defined shape, it's usually going to be grams divided by cubic centimeters, because 1 milliliter is the same as 1 cubic centimeter. What does that mean? That if I have a container, a cubic container, and it measures 1 centimeter on this side, and it measures another 1 centimeter on this side, and it's 1 centimeter high, volume is going to be length times width times height, which is going to be 1 centimeter by 1 centimeter, which is the same as 1 cubic centimeter. So if I have a graduated cylinder and I fill it up with water until the 1 milliliter mark, and I put it there, it will be totally full. In other words, 1 milliliter equals 1 cubic centimeter. So let's see how we can calculate, how we can use density as a conversion factor. Well, we know that density is grams per milliliters. Let's say water. Water have 1.00 gram for every 1.0 milliliter. And that's a conversion factor because you have 2 units in the form of a fraction. And this would be equivalent to 1.00 milliliters over 1.00 gram. We just flip it like we do with any conversion factor. So how can we use density as a conversion factor? If I have 45.5 milliliters of water, can you tell me how many grams that would be? Well, I want to go from milliliters to grams, so I'm going to have to do a conversion. I know that I don't want the milliliters, right? So I'm going to get rid of them because I want the grams. And what do we have here? Grams over milliliters. Exactly what we got there. So we're using density as a conversion factor. So 45.5 grams would be what we have in 45.5 milliliters of water. And since we're using significant figures, these are 3 significant figures, these are 3 significant figures, and these are 2 significant figures. So our result has to be 2 significant figures. So that's as simple as that. If you have been doing train track, if you know how to do conversion by eliminating what you don't want, carrying over what you want, density is nothing more than another conversion factor. So you should be able to do those 2 problems, right? And you should be able to do those 2 problems also. Let's see. Yeah, you should be able to do those 2 problems also. And once you do that, you know how to calculate density now, and you know how to use density as a conversion factor. And that brings us to the end of the chapter where we just covered that. And with that, we will soon be moving to chapter number 3. So be looking out for those. Those are coming up toward the end of this week. So see you later. Thank you. Have a great day.